Let's now look at another important and critical topic, that's on load balancer. These days, almost all the application server and web server has this load balancer in place to distribute the loads appropriately. So in this demonstration, we'll have first the presentation, we'll understand the load balancer concept, and then I do have a kind of a demonstration or hands-on as how you can set up a load balancer in the Oracle Cloud infrastructure. So what's a load balancer? Load balancer improves resource utilization, facilitates scaling, helps to ensure high availability. You can go up to we have a concept of okay, before getting into that, you have an application server or a web server. Normally for a web server you have an IP. So IP address, so that is actually mapped to a name, just like just an example like oracle.com, but it actually translates into an IP address, specific IP address. But during a peak season, say, or for that matter, better example could be Amazon. So if there is going to be just one server, web server, and the entire suppose millions of user is going to on a particular day when there is a high sales, if they are going to target Amazon.com, naturally, yes, there is overload. The web server could fail. So in that case, what happens is normally you'll have multiple web servers so that the load is balanced across to all of the different nodes or web server, each having the same kind of an application running. So that's where load balancer will be helpful to balance out the load or distribute the loads accordingly, so that even if there are tens and thousands of people are accessing that, it will not fail. And even if one is failed, they can probably it can route to the other server so that you don't miss out a particular day sales. So it's not just sale, it could be transaction as well, like a banking transaction. So it doesn't fail the front end or the back end server doesn't fail. So it fails over to another application server. That is where the load balancers are used. So you can configure multiple load balance policies, application specific health check to ensure load balancers directs traffic to only to healthy instances. This is what I said. Probably if one application server fails, the other one could take over, so that you don't lose your business or you don't lose the transactions out. So that is where it is helpful. There are two types as far as Oracle is concerned. One is layer 7, that is network, which predominantly use HTTP or HTTPS. Now any financial transaction, last about 10 years you are supposed to, any financial transaction, HTTPS is said to be secured. So hypertext transfer protocol secure HTTPS is what we are supposed to use, particularly if you are using something like a credit card transaction. You are supposed to use HTTPS rather than HTTP. Earlier days it was just HTTP, that is about a decade back. So flexible load balancer is of layer 7, and there is network load balancer. This is specifically for TCP other protocols, TCP, UDP, others. This is layer 4 network. That is the network. There are 7 layers. Will not go into the detail, but just have an understanding. Network load balancer is for layer 4. With flexible load balancer, it is at the layer 7. So this is what we have actually discussed also. Customer traffic will go into from the internet, it goes into the load balancer, and load balancer will have multiple servers, HTTP, or again could be HTTP or could be a set of HTTPS. This is just mentioning HTTP listener, then all will be HTTP listener. If it is HTTPS, all will be HTTPS listener, TCP similarly. So let's assume, in the example we'll be using a HTTP server. So all will be supporting HTTP, and HTTP the port is 80 as far as HTTP is concerned. HTTPS has a different port. It doesn't use 80. We'll see that as well. I'll see which port for HTTP. If it's HTTPS, you need to enable that port. So if it is HTTP, it is 80. So all the backend server has HTTP with the port enabled as 80. Or it could be all of them to be HTTPS. Particularly, say for example, if it is some financial transactions are going to be there, to gain confidence of the customer, you need to configure it for HTTPS. The SSL appropriate security will be there, so the security code needs to be installed as well. SSL needs to be installed as well. So this is the load balancer architecture and load balancer concept. Some of the terminologies we look at. Load balancer policy. A load balancer policy tells the load balancer how to distribute incoming traffic to the load balancer servers. The common ones are round robin, least connection, or IP hash. So this also we'll see while during the demonstration. You can also have, in the OCI console itself, it gives you a brief definition of round robin, least connection, and IP hash. Backend server, an application server, or in that case a web server, responsible for generating content. So when the IP goes, IP address, when the the browser has the IP address, it has to provide the necessary content. So that is called the backend server. So in other terms, application server is responsible for generating content in reply to the incoming HTTP or TCP or HTTPS also. You typically identify application server with unique combination of IP address and port. As I said, HTTP is port 80, HTTPS, if I am right, it is 443. The port needs to be enabled, the IP address needs to be for that specific backend server. So that's about the backend server. And then comes health checks. It indicates an indicator that reports general health of your load balancer and its components. Listener, a logical entity that checks the incoming traffic to the load balancer. You can configure listener protocol to port number and SSL setting. SSL setting is only for HTTPS. With HTTP, you don't require SSL setting. That is the so SSL means secure socket layer. So that is what SSL means. So that's about and SSL is required only when you configure it as HTTPS. With HTTP, it is not required. Backend set, a logical entity that defines list of backend server, a load balancer policy, and a health check policy. So that is what is a backend server. So with this terminology or concept, let's get into the before the demonstration, you need to have compute instance, 2 compute instance up and running, and you need to have the web server up and running as well. And that is the prerequisite to configure any kind of a load balancer. And then in the OCI, in the console, you can configure the load balancer. So let's get into the demonstration as well. Thank you. The first step is to have 2 instances up and running. That will act as the backend server. You can go up to 6 in a load balancer. As far as OCI, you can have up to 6 instances. So in this case, we are just going to have 2 instances. So you need to have the instance up and running. That is the first step. The next step is of course, the creation of the Apache server. So Apache web server. So these are the steps: sudo install, y install, run one after the other in if you are logged into the putty, and run one after the other, install, and then make a permanent entry into the appropriate firewall, reload the firewall after entry. Then you need to start the HTTP server. I have already done all these all the scripts are run. So in fact, you can also check this up whether it is up and running. For that, command is systemctl status .httpd. This is what you have to do. This is needs to be active. It'll otherwise, if it is not there, it'll respond back about the HTTP, but it will say terminated or stopped. So this needs to be up and running. And more importantly, you need to have an index HTML page. So that's what I have mentioned. Echo, you are visiting web server. Since you have two server, the first one is of course needs to be HTTP 1, web server 1, and for the other one you need to have it as web server 2. So the index, if you go into this one, into this directory var wdp www html, let me check that as well. Say for example, change directory, then it becomes var, then www ls-l, change directory html ls-l, so ls-l index. So here you have. So this is what it creates. So welcome to this is for the web server 2. I mean this what I'm saying is this scripts creates the HTML. So for the two of the instances, you need to create one with web server 1, the other one with web server 2. The index HTMLs needs to be in place for the both the compute instance, so that when you trigger it, you'll get that appropriate appropriate information in your browser. We'll see that. That is the first step is this one. The next step is ensure you have an entry with port 80 entry in your VCN. So just check that you have an entry, otherwise you need to have an entry. So to do that, get into the network, virtual cloud network, and need to have an entry. I already have this entry, my VCN, and get into the security list, default security list, and there port 80, there need to be an entry, allow traffic on port 80, allow HTTP. Otherwise you have to add an ingress rule here, add an ingress rule, and that will create the appropriate entry. I'm just giving that CIDR. Then you need to have this one 000 CIDR entry. TCP port 80 is for HTTP. So when you are entering, newly going to enter, yes, you got to add the ingress rule, and then of course save it. So I already have this entry in place, so I'm not going to do anything. Otherwise, the first one is run the scripts, and the next one is have the port entry. So once this is done, you can always verify it whether it is up and running. So I mean, take the IP address. You got to get into this IP address. I'll just copy this IP address, and then I'll open the browser and copy that specific IP address. So it says, welcome, you are visiting web server 1, and this is HTTP. That is where it says not secure. If it is HTTPS, you will have a lock sign over here, and your connection is not secure. So this is about, as I said, about 10 years back is what you are supposed to use HTTP, particularly if you are making financial transaction. HTTPS you are supposed to use, and you need to enable it. Currently it is on HTTP, and that's why it is getting in from the index.html, and it is throwing this message. This is for the web server 1. You also have web server 2 up and running. After the running of the scripts, I have the web server 2 also up and running. So this is web server 2 up and running. So this is directly without any load balancer. There is no load balancer as of now. I've just created the 2 web server with my compute instance. So the next step is we will create, through the OCI, we will create the load balancer and assign this as a backend server. These 2 IPs as a backend server. And load balancer will be using the load balancer IP. When using the load balancer IP, you will see it distributes load between 2 of the server. We will see that once you configuration of the web server, the load balancer is done, you will see that depending upon the load, it will go to either web server 1 or to web server 2. We will see that and progress into the configuration of the load balancer. Thank you. Let's now get into the configuration of the load balancer. To do that, get into the hamburger menu and networks, and that is where you find the load balancer. So now, we'll create the load balancer. So there are 2 types. One is with layer 7 is what we have to try, because we are going to use the HTTP listener or HTTPS. If it is SL enabled, then you need to use HTTPS or TCP IP. Only in case of the other protocols, you need to use the network, which is at the layer 4. This one is at the network layer 7. So create the load balancer, and it will get into the details which you need to provide. So let me say load balancer name, it's LB load balancer, let's give some name, balancer web 1 or web. And public IP is what I'm going to, because it will automatically, you get a public IP address assigned to the load balancer. So let's use the public IP load balancer. If you want to have the private like 10 dot something, then you can use private. Otherwise reserved also you can use. Choose the bandwidth. All this I leave it as default, whichever the bandwidth. And here is what you got to choose, whatever the VCN, and ensure that that VCN has an entry of port 80, which is should allow the traffic. And public subnet you need to allow. And the advanced feature, nothing much you need to fill for now, but otherwise depending on the project requirement, you might need to use. I'm leaving it I'm not going to get into the details, but depending on, say for example, security, use web application firewall policy to protect against, this is against, maybe you need to, if there is a malware, then you need to use enable it, so on and so forth. So I'm going to leave this. This all fine. Name, only thing is name, public, and bandwidth I'm leaving it to default, and then I'm going to get into the next, and here is what is the type of the policy. So weighted round robin, the policy distribute incoming traffic sequentially to each of the, so it will go depending on the load, it will sequence IP hash. It can direct, this policy ensures the request from a particular client is always directed to same. So if there is some kind of a priority from a particular client related IP, then you can use IP hash. Least connection, this policy routes incoming traffic requests to a backend server, the fewest active connection. This is almost similar, but yeah, weighted round robin distribute incoming to each of these. So we'll use the weighted round robin, and here HTTP, let's see, I'm not going to use TCP, I'm just going to use HTTP protocol over here, and that is what is the port. I'm not going to use TCP at all. So HTTP incoming path, SSL is again only for if you are going to use HTTPS. So this case, then you need to provide the SSL certificate. I'm not going to use it. So we need to add the backend server, both the backend server. So add the backend server. This will list whatever in that particular compartment which is there. So this will list the backend instances. Both the instances, web instances we are using. Select that. So this will automatically default the backend server details. Port is 80. Show advanced. You give the name of the backend server, LB web set. I'm just giving that name. Security list. It's all defaulted, and sessions preference disable. And again, if you want to know more details about it, you can always see that. I'm going to leave it as such. With weighted round robin, I have given choose the backend. So here again, you can go up to 6 backend servers. For now, because we have used only 2, I have provided 2 of them. Details of 2 of them. HTTP is fine. Timeout URL is fine. So next comes the listener. So again, just give the name. LB, then listener, LB listener. And here, yes, if you look at it, 443 is for HTTPS. So if you are using SSL certificate, that is highly, these days almost all 90% of the web server has HTTPS. Very few has HTTP. We are using HTTP just as an example. If you're using HTTPS, then you need to provide these certificate details. So I'm going to use HTTP only. That is where the SSL details just disappears. So HTTP I'm going to use. So listener name you need to provide, and say next. So this is all fine. So let's just once again recheck everything. I given the name, I chose HTTP, port I have specified 80, and I have all the add backend servers. I have done it already, so I'm not going to change anything. So previous, again, that is just the details. I've chose the VCNs, all looking fine. So let's now create it. Lock group, I will not choose it. So let's say submit. So here, I mean, you got to give the default lock group. We need to select. That's why it didn't get submitted. Let's now check. Submit. Yeah, it's creating. So this will take, I mean, some time. I mean, overall health check. If you look at it, let's see what it refreshes. It takes anywhere between a few minutes, sometimes like 5 minutes, depending upon your network. So it's creating. So let me pass here, and yeah, it shows overall health is pending, backend set health is pending. So this should turn green when we start using it. So let me regroup, I mean, come back once again once everything is done. So all done. If you look at the overall health, it says okay, and this is the public IP address. This is what we have to note and just check in the browser. So go to the overall health is also saying okay. So if it is something critical, warning incomplete, then you need to troubleshoot. For now, you don't need to do anything. It all looks fine. So go to the load balancer, active, and it gives the IP address. So we will see, we'll test it out with the IP address in the next presentation. Thank you. Now that we have the load balancer up and running, this IP address is what we need to, we need to, through the browser, we need to have this IP, because this is renting the backend server. So this is what we need to provide the IP over here. And the other one also, let's have it over here. So this is going to the web server 2. Let's refresh again and again, and now it is 1. So because because it's a round robin, we see 1 and 2 based on the load. Yeah, it is going to the appropriate backend server. You see web server 1 and then web server 2 also coming. Now it is web server 1, and if you do it web server 2, that means with the load balancer is working effectively, and it is able to route traffic through both the web server. This is how an actually website, bigger websites like e-commerce website like for example Amazon.com, or even ERP application also, because of the load, they will have the load balancer in place, and they will have multiple server, and it will route traffic based on the policy you have chosen during the configuration of the load balancer. I hope with this example you are able to understand about concepts behind the load balancer. Thank you.